Right, good morning again, you lucky students, Year 13 MAC. My gosh, we're making huge progress today. Okay, now I'm going to show you a nice, easy peasy integration. Don't I always show you nice and easy peasy integrations? Anyway, here it is. You might be asked to integrate something like this. Now, what does that ferocious looking thing say? It says that you've got a derivative of a function on the top, numerator, and the original function is in the denominator. If you recognize this, then the answer is straightforward that. It's the natural log of the original function. That's it. Now, so what I've really said, I've really just put that in words here. In other words, if you notice that the numerator of the integrand is the derivative of the denominator, then the answer is straight away the natural log of the denominator. All right, an example. Here we have something that looks pretty horrible. But if you look at it carefully, you can see that if you differentiated this denominator here, you would get 3x squared. And that is what's sitting on the numerator. So immediately you can write that the integral of this thing here is the natural log of the absolute value of this denominator, x cubed plus 1 plus c. That's it. End of story. Let's do one more. Okay, just imagine you've got this thing. You've got 7 plus, you've got to integrate 7 plus e to the x all over e to the x plus 7x. Well, if you differentiate this denominator, you will get that thing there, the numerator. So immediately you can say that the integral of that thing is the natural log of that denominator, e to the x plus 7x plus c. All right, now I'm not going to show you any more examples of that because this particular thing is very easy, but you have to be on the lookout for things, that where the numerator is the derivative, the exact derivative of the denominator. And if that is the case, then it's always the natural log of the absolute value of the denominator. Okay, now I'm just going to zoom out because I want to show you the examples I want you to try for yourselves. Okay, so if I go to the next page, and now I'll zoom in again here and just go through a few of the ideas, and then I'll let you loose. All right, now it says here, yeah, I've written down about, I think it's 8 integrals. It doesn't look like it wants to fit exactly on my page. Let's do that. Yeah, that looks a wee bit better. Okay, so what I've gone and done, I've said that the clue here is that these are a mixture of all the techniques that we have learned so far. So there is something you can try and integrate. Here's another thing you can try and integrate using the ideas we've been talking about. Again, here, and then here a one that involves some trigonometry. Here we have something which you might recognize, and here at the end they get slightly more challenging. Here I would recommend that you multiply out the numerator first, and then you might spot something. And this one here, this one will sort out the geniuses amongst you, but you must use this trigonometric identity to rewrite the integrand first. Okay, this is going to be a taxing one. Okay, number 7. If you can do number 7, then you're doing very, very well indeed. And this one, I think, is probably the easiest of all. Now, I'd like you to try these first before I give you any answers, okay? I will put up the answers. I'll work them all out for you, and then you can, check how well you did. All right then. Thank you very much. And there'll be more videos coming fairly soon, I hope. Okay? Bye-bye.